Today we're going to talk about the braking systems on a Formula One car, how the various parts work individually and how they work together as a combined system. So when a driver presses on the brake pedal in a Formula One car, the force he's applying to the brake pedal is applied to two master cylinders. One cylinder is a fluid that's linked to the front brake system and the other cylinder is linked to the back brake system. And that pressure in that cylinder goes through a brake line and onto the caliper, onto the brake disc itself, and that pushes the pads onto the disc, and that's what slows the car down. On the back of the car, the system's a bit more complicated than that because we now have energy recovery systems and we need to deal with those to get the brake balance right. In your road car at home, when you press the brake pedal, you have an assist system, a servo assist, so that multiplies the pressure you're applying into the master cylinder to give you the braking effort. On a Formula One car, we can't do that. What happens is the driver has to apply all that force, so it's a huge amount of effort the driver's making. And in fact, if they were to just sit in the car normally and apply the brake pressure, they couldn't press the pedal hard enough. In order to do that, what happens is they're actually using the deceleration of the car and their own body weight sliding in the car to actually get the amount of pressure that they need. So the driver's not only having to press the brake pedal really hard, he's also having to withstand the huge G-forces. So that could be a G level of sort of 5, so that's 5 times the pressure you get of gravity. So if you imagine his head and his helmet's sort of between 5 and 10 kilos, so that peak part of braking, the driver's getting as much as 50 kilos into his neck. So if we look at a brake disc, this is a brake disc off a Formula One car. When we're braking at maximum brake temperature, so on a high duty circuit, the temperatures could be up to 1000 degrees C on one of these carbon discs. As the car goes down the straight, the air's coming through the brake duct, coming out through the upright, and that's cooling the disc itself. So by the end of the straight, the temperatures could be as low as 200 degrees C. And those temperatures are really important. The disc itself has up to 1000 holes, and they're there just to try and get the maximum surface area and the maximum cooling we can achieve. In actual fact, because we've removed so much material from the brake disc, the peak temperatures are actually higher because the thermal mass of the disc is lower than it would have been years ago. But it's not that individual peak that's important, it's the repeated braking that occurs. It's those repeated brakings where we don't get the disc cool enough by the end of the straight and the temperatures come back up. That's when we see these really high temperatures. So what we're trying to do is get as much cooling as we possibly can. It's important to understand why handling the brake temperatures is hard. If the disc gets too hot, so when we talked about that 1000 degrees at the end of straight, what happens is we start seeing fade. So it's a bit like a car going down a hill. When you get to the bottom of the hill, sometimes the brakes are less effective, and that's because the discs are too hot. Equally, if the discs are too cold, something we might see at the end of straight, then we don't get the bite, we don't get that initial braking that we're looking for. So we have to manage the temperatures of the discs really well. And we do that with the flow that's coming through the brake ducts here. And that flow is fed through the duct and through the upright and onto the disc. It's also there to cool the caliper and also the pads that are inside the caliper. All of that has to be kept at the right temperatures to get the peak braking performance. It's also really important how we deal with the flow that comes out of the disc, that hot air that's trapped within inside the drum. How that feeds over the wheel rim and also around the tyre is really important for the tyre performance because we need to keep those in the right operating window too. You may have heard on the TV the drivers talk about brake balance and also brake migration. So what's happening there is it's important to get the amount of braking effort at the front and the braking effort at the rear in the right balance. Because what you're trying to do is maximise the rate at which you decelerate. So it's really important that you're extracting the most grip from the front tyres and from the rear tyres. And we do that by changing the balance, and that's an adjustment the drivers can make inside the car. When we talk about brake migration, what we're actually talking about is the balance migration. So as the driver presses on the brake pedal, we also alter the balance front to rear using the energy recovery systems to get an optimal braking performance. On a typical road car, you might be able to brake at, say, around about 1G. On a Formula One car, at peak braking, we're braking at nearly 5G. And the reason we can do that is, one, the tyres themselves have more grip, we have more powerful, more capable brakes, but we also have the aerodynamic performance of the car. At the end of the straight, the aerodynamic load might be 3, maybe even 4 times the total weight of the car, and that load is pushing into the tyres, and that allows us to generate much more grip at the tyres and therefore more braking performance. So one of the questions we quite often get asked is, why is it so difficult to brake into the first corner? But as we talked about earlier, it's really important to have the right temperature in the brakes. So if the brakes are sitting there cold because we've been sitting on the grid waiting for the start, the drivers don't really know quite how much grip they're going to get from the brake system, quite how hard they should press the brake pedal to get the right braking force. If they don't press hard enough, then they could lose their advantage into the first corner. And if they press too hard, then they could lock up the brakes and go straight on. So it's difficult to get that balance right for the driver. So two of the most difficult tracks for the brakes are Monaco and Baku, but for different reasons. In Monaco, the problem is that the car speed is generally low, so we don't get the huge amount of air rushing through the brake duct we might get at faster circuits. But what we've got is these repeated corners. So each corner, the brake temperature rises as we press the brakes. We don't get enough cooling down the next straight, then we get another application of the brakes and the temperatures keep going up and up. So that's one that's really challenging for the brakes in terms of the maximum temperatures. In somewhere like Baku, Baku is a funny circuit. It's got half like Monaco and half more like Monza, so a high-speed circuit. So what happens there is we're having to give enough brake cooling for those twisty parts of the circuits where the average car speed is low, but then we've also got these huge long straights, which means that the brake temperatures get really low at the end of straight. So going into those corners after the very long straights, the brakes are cold and therefore they lack the bite that the drivers would want. In these different circuits, we have to manage the brakes, and that's the drivers and the engineers working together. The engineers determining what the right setup is, and the drivers knowing how they need to manage the brakes within the race.